My first product in the rotomolding process was the duck, and this product was an example of low density polyethylene. And from what I could tell, all the molds were aluminum, and the duck mold specifically had moderate wear and some burnt on plastic that, with some good time, could be chipped away a little bit at a time, but there was a good amount of buildup. My machines and equipment for this were uh, the oven, the sink, the mold, and the backing plate, as well as everything that was used on the table. And then the timing for all these machines were 20 minutes in the oven and approximately 2 to 3 minutes in the sink. This item had a pre-measured amount of low density polyethylene and about 4 scoops of colorant. Some of the problems with this product after the process was completed: the duck's beak was not fully formed, it was leaking colorant, and the surface was very porous. The first high density polyethylene item that I will be reviewing is the pumpkin, and that I believe was also aluminum, and it was in much better condition compared to the duck, I believe, and it did not require as much time to properly clean and remove any debris. Once again, the oven, the sink, the mold, and the backing plate were required, and the machine time was 20 minutes in the oven and 2 to 3 minutes in the sink. This was also pre-measured in a plastic cup, and I counted 3 scoops of colorant for this product. And when this product, after it was taken out of the oven, the mold was unscrewed, and the plastic was in half, completely filling each side of the mold, but did not fully form. And this was due to not being in high enough heat for the material it was made of, and also not being in the oven long enough. The next item that utilized high density polyethylene powder was the Christmas tree. As far as I could tell, the mold material was also aluminum for this one. The Christmas tree mold was in very good condition, and I was not able to tell very much buildup of plastic, and not very much cleanup was required beforehand. Once again, same machines required: oven, sink, mold, and the backing plate. This was put in the oven for 30 minutes and then set to cool in the sink for 2 to 3 minutes. In this process, the amount of high density polyethylene was eyeballed just to fill one side of the mold halfway. And this product was leaking pigment, and color was coming off, and the thickness was very inconsistent. The final item was the clover, and the material that it was made of was low density polyethylene. Once again, aluminum mold material from what I could tell. It was in, I'd say, medium condition. There was some burnt on plastic in the outer areas. Oven, sink, mold, and backing plate were required. Just like the tree, 30 minutes in the oven, 2 to 3 in the sink, because they were paired together. Once again, half of one side of the mold was filled with the powder, and when it came out of the oven and was removed from the mold, it was leaking water. Once again, there was some thickness inconsistencies, and there were some significant holes where the plastic had not fully attached to the mold and formed. One thing to ensure quality, from what I could tell, given my best guesses, I believe that one thing that would increase the quality is pairing the two materials of like kinds together. So the duck and the clover were the two low-density polyethylene items, and the tree and the pumpkin were the two high-density polyethylene items. And the low-density polyethylene items, I say, would ballpark be at around 400 degrees in the oven for 25 minutes to fully melt and be able to form a good part. And for high-density polyethylene, a little bit hotter and a little bit longer at 450 degrees for 30 minutes. I believe one generous scoop of pigment should work for each part if it is thoroughly incorporated beforehand. And I think this is because there was pigment leaking from a good amount of the parts, and they had upwards of 3 or 4 scoops. Ways that I think this process could be improved: to start, learning what temperature is best for each material would be most beneficial, because having the product in for too long could make the product not structurally sound, and it could also be a waste of time and energy, as well as if the temperature is not high enough, the mold will not be fully formed and the product will be compromised. So I believe both materials should be tested for each item to see which is going to be the easiest to produce and the best quality. A process and a step beforehand should be to measure out the powdered plastic and colorant desired for each item, and if you're going to making a great amount, there should be individual servings, basically, so that you do not have to go through and measure each time. You can just pour directly into the mold and reseal it and put it right back in the oven. There were some troubles with the tooling. Some of the molds could stand to either be deep cleaned, or a new mold could be purchased or created to keep the product secure, and some of the screws / Allen keys and wing nuts could be replaced with newer ones to make just the process a little bit faster and save time. Using gloves that are heat resistant as well as water resistant could prevent the need to be as concerned with the water getting in the gloves, which was the problem that was brought up in the video, with steam burns being the likely cause of injury. And then, like I said before, pairing the parts in the mold that require similar heat and time in the oven. In the process, the two items were paired together in each video were not the best candidates to be put together because they had different requirements, and I think that was made pretty obvious in the output of each video. And like I said, in the specific step process beforehand, the colorant should be fully mixed in with the powdered plastic. That'll prevent the majority of inconsistencies with pigment. And like we did in the 1120 lab last year, we would want to find the most efficient path through the lab and number the processes in the directions so that any person coming in would know where they would be taking from in the order of each station, next to next, to complete the product or a number of products in the most efficient fashion without wasting much needed time and resources. And that's it.